Okay, today I'm going to dive a little bit more into how to solve a quadratic using the factoring method. First thing I want to point out, now the problems that we're going to do today, they are factorable. So this is a possibility, but there are quadratics out there that you can't factor. So they have to be solved a different way. But this one, if you're decent at factoring, it's the first thing I go to. I'm not going to graph. I'm not going to go through the steps of the quadratic formula. First thing I'm going to always check, can I factor it? And you'll see why. That's always the first option. Before we do that, just a quick recap of what it means to factor. And we're breaking it up into, most of the time, into those two binomials. And so if you haven't watched those videos and done those practice problems, you should not be moving on to this section. So in this example, the a value is a 1. So we know to get x squared, because they don't all have x's that can factor out, it's going to be x times x. So I put those first into my binomials. The next part I try to look for is I want two numbers that multiply to give me that c value that add up to the b value. Now I've already got the minus signs in here because in order to get a positive that adds up to a negative, it has to be two negatives. And then we just run through our possibilities on how to get to 35, 35 and 1, 5 and 7. Oh wait, 5 and 7, that would add up to 12. So we have 5, we have 7, and now it's been factored. The key to using factoring as a solving technique for quadratics is the zero product property. If you are multiplying two values and they come out to be 0, one or both of the values have to be 0 for that to happen. It's the only way to multiply and get 0. So we're going to use that to our advantage when we factor these things. We know if we have it set equal to 0, one of the binomials, or possibly both, would have to be a 0. Prior to solving, you need to make sure that the quadratic is set equal to 0. If it's not set equal to 0, you need to do that first. You can see that in example 2. But example 1's good to go. So we're going to take a peek at it. It has a 1 in front of the x squared. So the question we're going to ask ourselves, what two numbers multiply to give us negative 15 and add up to negative 2? If I look at the symbols, they're going to multiply to give me a negative. So that tells me I'm going to have a positive and a negative in my binomials. So you also have to be careful when one's positive and one's negative on where you put the numbers. So 15, we want them to come out to be 2 spots away from each other. So it's not 15 and 1, 5 and 3. That's it. So 5 and 3 multiply to give us 15. One of them has to be negative. And when we add them together, it needs to come out to be a negative. So we need the bigger number, which is the 5, to be negative. Now before when we were factoring, we're done. But now we're trying to solve. We want to know what are the values of x that give us 0. Now you're not putting a 0 in. That's not what the zero product property is saying. It's saying this thing needs to equal 0 or this thing needs to equal 0. So a lot of times you don't even have to show any work for this one. I will write it down. If we have x plus 3 equals 0, and x would be negative 3. So that's one possible answer. If I put in negative 3 into this trinomial up here, I'm going to get 0. You could check it. Let's check it. Negative 3 squared is 9, minus 2 times negative 3, which is plus 6. 9 plus 6 is 15. 15 minus 15 is 0. Repeat that same process for the second part, because this one could also be 0. And if I don't want to write it down, 5 minus 5 is 0. So the other answer would be positive 5. So when we have that 1 in that a value spot, something nice happens. You just get the opposites for your answers. That's not always the case, so you just got to be careful. And that's where that setting up that equation is useful. And the second problem, first thing we need to do is get the 24 over on the other side with subtraction. So it should say g squared plus 5g minus 24 equals 0. So now that first step is done. Now we can think about what are the possible ways to factor this. It's a g squared, so it's got to be g and g. It's going to come out to be a negative like that last one, so it's got to be a positive and a negative. And then we think about negative 24. So 24 and 1, no, that's going to add up to 23 or negative 23. How about 8 and 3? Yep, 8 and 3 are 5 spots away from each other. So again, be careful on where you put them. We want to get a positive, so we want the bigger one to be positive. So we got 8 there, 3 there. You could check it with the distributive property. So to get our answers, we know that we want this to equal 0, which would be if g was a negative 8, or we'd want this one to equal 0, and so g would have to be 3. And those are the solutions, negative 8 and 3. Last one, you might notice that there is no c value. There's no number in that trinomial. It's actually just a binomial. But the other thing we should notice is they do have an n in common. So we're actually going to factor that part out first and then see if there's more stuff we need to do. If we take the n out of n squared, we're left with an n. If we take the n out of the 12n, we're left with a 12. So it's not a quadratic anymore. There's nothing else we can do. So now we're going to get our answers. This one's the same as up above. N could be negative 12. But then also, this could also be a 0 because 0 times this stuff would give us a 0. So the other answer is it could be a 0. Now what's happening there? That is this idea right here. If you are factoring something out, so if the greatest common factor contains a variable, sometimes it'll just be a number, then this doesn't hold true. But if you factor out a variable or variables, then 0 is a possible solution. One last example I like to look at is just an application of quadratics. Now this could be done with guess and check. It could be done with drawing a picture, but kind of interesting right now because we shouldn't be shaking hands. So hypothetically, if we walked into a room that was full of a bunch of people and everyone walked around and introduced themselves to everyone else, how many handshakes would occur? Now the formula is pretty simple, and I'll actually tell you where this kind of comes from. If you think about yourself as being n, you can shake n minus 1 hands because there's one less person in the room when you take yourself away. But because someone else is also going to do the same thing, we don't want to double up, and so you divide by 2. So that's where this formula comes from. N times n is n squared. N times negative 1 is negative n, divided by 2. So we're going to set this thing equal to 66, and now we're going to solve it like the other problems. We're going to factor. Now this isn't a difficult one that you could sit there and you could throw numbers in until it came out to be 66. It would not take you very long, but I still just want to show another factoring example. So we don't like that it's this giant fraction over here, so we're going to get rid of that by doubling. Sorry for that. Okay, we want to be set equal to 0, so we can use that 0 product property. So we're going to bring the 132 to the other side with subtraction. Now we can factor it. 1 in front of the n squared, so we know it's going to be n and n. It's going to be a negative, so we're going to have a positive and a negative. And then we think about how many different ways you can get 132. But I want them to add up to negative 1, which tells me they need to be one spot away from each other in terms of their digits. So the little thinking, it is 11 and 12 is what gives us 132. We want the bigger one to be negative. I'm going to put 12 over here, 11 over here. And when we solved them before, the two answers would be n equals negative 11 and n equals 12, positive 12. But this is an actual situation where we're talking about people, so the negative answer doesn't make any sense. You can't have negative 11 people, and so the answer is 12. There's 12 people in the room.